Problem number 30 asks us to solve 4 different triangles, each with given information about the size and the angles, and determine what else, what are the missing pieces of the triangle, what are the missing measurements. So problem number 30 is the last one. Part A. Alpha is equal to 70 degrees. Side A length is 25 whatever units of some sort. And side C is 26. Draw a picture out. See what's going on. So we've got A being 70 degrees, or alpha. A is 25. Let's call this guy up here gamma, this beta. So this guy is 26. And this is B. So we've got a situation where we have an angle, a side and a side, or side-side angle. So now we have to be careful with this because odds are we're going to have, well, we're in the ambiguous case. So we don't know. We could have 0 triangles, we could have 1 triangle, or 2 triangles. We don't know. So let's check that out. So we use the law of sines. And so we've got the sine of 70 degrees divided by its opposing side is equal to the sine of gamma over 26. So solving that, oops. So I'm getting, yep, that doesn't look right. Let's try this again. So the sine is 70. It's 0.93. We're going to then, okay, so now I'm going to divide that by 25. And I'm going to multiply that by 26. Okay, so I'm getting 0.977, we'll say. That's equal to the sine. Now we're going to do the arc sine here of this guy here. So we'll do inverse. So 77.76 degrees. So gamma is 77.6 roughly degrees. Okay, that's what I'm getting here. Now what I need to do is I need to check to see if there's another triangle floating around in there. So how I do that? So I've got one triangle for sure. Okay, let's see if there's a second one. What I'm going to do is I'm going to take that 77.6 and I'm going to add it to the 70. Okay. Excuse me, I'm sorry. Before I do that, I'm going to take 180. I'm going to subtract 77.6. So the 102. And then I'm going to add that to the 70. I'm going to see if I'm under 180 still, and I am. So that means that 77.6 could be an answer, or that 180 minus the 77.6, so 102.4. Those are both these. Okay, guys, so let's not get confused here. Here's the deal. These are both angles that work for this. They both solve this setup. So these proportions that are set up here, both of them are solutions. So since both of them are solutions to our original setup, we've got 2 triangles going on here. We've got, when I say they're both solutions to this, they're also both solutions to this triangle. It's possible that this first triangle, called triangle number 1, triangle number 1 exists. Triangle number 1 satisfies this initial set of conditions. Triangle 2 also satisfies that initial set of conditions. So there are 2 triangles out there that are possible solutions for what we originally started with. It's like if I went into the classroom and I said, I'm looking for a person who is over the age of 20. It's very possible that there could be two people that are over the age of 20 in my classroom. They both satisfy my initial criteria. So now I need to figure out the rest of this. So I need to get what beta and b are in both these two separate triangles, and that gives me my solutions here. So what we would do then is we would go back through and we do sine beta over b is equal to, it's probably easiest to do sine alpha. Well, by the way, I'm sorry. To get the beta values first, I can get the angles very easily here. So what I'd end up doing is taking 180 minus the 77.6 and then subtracting off this 70. So 32.4 in this triangle. And in this triangle down here, it's going to be 180 minus the 70 minus the 102.4. So 7.6. So this is a real small angle down here. And to figure out the side lengths for B, you just go ahead and repeat this process here. So we go sine of B, so 32.4, over B is going to be equal to this sine of alpha over, 25. Okay, and you just go ahead and solve that for both of those. So on the first triangle, the B value, so 32.4, I want the sine of that guy, times that by 25, and then we want to divide that by the sine of 70. So 14.25. You should look to see it. Does that make sense? Well, look, this is about half the size of those, so odds are the angle across is going to be roughly half the size. Now, that's not a for sure way of doing that computation, but when you look at it, it's not like, look, this was the biggest angle and I got the smallest side length or something like that, so it doesn't make sense. Okay, when we try this one over here, let's see here, we need the sine of 7.6, so that's going to be a really small, it's a really small angle, so it'll give us a fairly small sine value. We're going to multiply that by 25, and then we're going to take that number and we're going to divide it by the sine of 70, and that gives us 3.52 roughly. Now, smallest angle, smallest side. So it should make sense. It should match up. So that one had two solutions. Let's look at B, the next one. B says that alpha is 73 degrees, A is 5, and B is 7. So again, we'll draw out our triangle. So 73 degrees, 5, say that's beta. Doesn't really matter where you put these guys. Okay, as long as they're across from one another, where they're supposed to be. Okay, so let's use our law of sines again. Now, in this situation, again, I have an angle. So I've got a side, and then an angle. So we're still in the ambiguous case. How many solutions do we have? Well, we'll try again. We'll go sine of 73 degrees over 5 should be equal to the sine of beta over 7. So here, I've got the sine, oops, so 73 degrees, the sine of that, divide that by 5, multiply that number by 7, I get 1.3 something. This isn't going to matter because watch. At this point we can stop because there is no angle for B whose sine value is above 1. So there's no solution for this. So no triangle has these dimensions. There's not a single triangle out there that has those dimensions. so we'll try this one. We'll draw out our picture again. So our beta is 105 degrees. The side opposite is 23. Here will be our alpha up here. So side A is 14. Here's our gamma and C. Now, again, we've got a side-side angle, so we're in the ambiguous case. So what have we got here? Well, to solve this, look, I've done one that's 2 triangles, I've done one that's no triangles. This probably has 1 solution, but let's check. So here's how it's going to work. The sine of 105 degrees over 23 should be equal to the sine of alpha over 14. So 14 sine 105 over 23 is equal to sine alpha. So we'll grab our calculator, and we'll do 14 times the sine of 105, divide that by 23, and I'm getting 0.588. So now we'll take the arc sine of that value, okay, and we're getting 36. Degrees roughly. So this is saying that this is about 36 degrees. Now what we'll do is we'll take 180 minus that 36 to check to see if there could be another triangle out there. Instead of this, we want to check this. 105, 144. Problem with this triangle right here is it doesn't exist in a two-dimensional plane. So this plane figure doesn't exist because 105 plus 144 is way more than 180. So this guy doesn't exist out there, so we can just get rid of it. So that tells us that we only have one triangle. So then we just need to solve the rest of this. So we know that this angle for gamma here is 180 minus 36 minus 105, so 39 degrees. So it's going to be really close to 14, because if this was 36 and it gave me 14, then 39 should give me just a little bit more. So to solve for that, we've got the sine value times, let's see here, we'll do times 23, and then that value divided by the sine, the sine of 105, let's go. Hang on, I gotta clear and redo that. Okay. So we're gonna have, let's see here, the sine of gamma, so 39 degrees, the sine of that guy. It's gonna have to be multiplied by the other side length and divided by the sine value of the side that we know. So I'm getting 9. That's clearly not right. Okay, let's write it. We'll write it out. Let's see where I'm goofing up here. So sine of 39 degrees over c should be equal to the sine of 105 over 23. That's where I was messing it up. Okay, that looks better. So let's try that one out. Now you notice that when I got an answer out, I looked back and said that doesn't make any sense. It shouldn't be definitely less than the other side. So when you're working through the problems, just like I do, check your answers as you're going through. Make sure, yeah, this does make sense or it doesn't. Okay, so let's do this again. So 105, the sine of that guy, excuse me, 39. I don't want the hyperbolic, I want the regular. Okay, the regular sine of 39 times that guy by 23. Take that guy and divide it by sine of 105. There, 14.98 or about 15. And that looks good. It should be just more than that value right there. We got time for one more. Let's quickly do this last one here. So our angles, excuse me, our sides are all given to us for D. So for D, A is 14, B is 9, C is 6. If you don't know what to use between the law of sines and the law of cosine, just try using the law of sines. If you try it on this, you're going to see that there's not enough information given to you, so you can't use it. So when we want to find an angle, let's say we want to find alpha, what we do is we put A on the other side, we put B and C, and we want to solve for this. So this is going to be 14 squared minus 9 squared minus 6 squared divided by negative 2 times 9 times 6. And then we want to get alpha, we want to take the arc cosine of that. So I just need to plug that guy into my calculator. So the law of cosines is just more computation than really anything. So 14 squared plus minus, okay, plus a negative. Now, I don't like how this is. It's so much more difficult than that calculator. Let's take a look at it. Let's grab a regular calculator here. So we've got 14 squared minus 81 minus 36 divided by negative 2 times 9 times 6. And now I need to take the arc cosine of that value. Okay. Oops. I need to be in degrees. So that's the radian value. So we'll do arc cosine of negative 0.7314. So 137. Okay, and then you do the same thing to get your beta value. Your beta value is going to be the arc cosine of 81 minus 14 squared, which was 196, minus 36 over negative 2 times 14 times 6, like that. Okay, so I'm getting 26 degrees for beta. And now, of course, you can check the last one to see what you get, but you could just take 180 minus those two, and that'll give you your third angle. So if you take 180 minus 137 minus 26, you get 17 degrees. So gamma, 17 degrees. Smallest angle, smallest side. Largest angle, largest side. Middle, middle. So it's an easy way to go back and check to make sure you're solving these correctly.